Can I start?
Hello,
Or
Sudipto?
Yes, Amit sir.
I think YouTube is not working correctly.
Huh?
Yes, yes, now it is working. Okay, okay.
Okay, fine. Okay, sir. Then we are going to start it. Hello, ma'am. Good evening.
good evening, good
Okay,
afternoon.
just we are going to start it. So let me just record it on out. Okay, sir. With your permission, I am going to start the program.
Yeah.
Thank you, sir. Thank you.
Go ahead. Yeah.
Ladies and gentlemen, a very good evening to you all. Your host for this evening, this side Sudipto Sahana, Assistant Professor, Department of Computer Science and Engineering, and Student Branch Counselor, CSI Student Chapter, JIS College of Engineering, West Bengal, India. Welcome you all in the fourth day of the one-week International Faculty Development Program on Advances in Technologies Evolving New Dimension in Society, which is organizing by the Department of Computer Science and Engineering, JIS College of Engineering, West Bengal. Today we have with us the expert from that is from Italy, Dr. Gabriella Castellino. She is from Department of Informatics, University of Bari. Dear participants, I hope all of you have enjoyed the 3 days that we have passed, and we are currently at day 4. So before commencing the program, just I would like to share one more thing, that we have our participation from across the globe, and from India, almost every state we have our participation. So commencing with the program, I am requesting Dr. Dharampal Singh, HOD, Department of Computer Science and Engineering, JIS College of Engineering, and coordinator of this FDP program, to give the welcome address on behalf of JIS College of Engineering. Please, sir.
Thank you, Sudipto. Thank you, everyone, those who have joined here. So also today is the auspicious day in India, and most probably Gabriela don't know. So do you know, Gabriela, today is the Teachers Day in India. We are celebrating Teacher Day on the 5th September. So whatever the participant and person have joined on behalf of the CSE department, JIS College of Engineering, I would like to wish you happy Teachers Day. So, and also I would like to welcome all the participants, those who have joined here. Also, I would like to welcome the today lecture expert, Gabriela Casalino, who have from the Computer Science Department, University of Daegu, study di Bari, Italy. So thank you, Gabriela, for within the short period of time you have given confirmation and joined this FDP. So as you know that Teachers Day, in the Teacher Day, we show respect to our teachers. So this is a very auspicious moment for us, that we are getting the knowledge on the Teacher Day from the teachers. So it is a very good thing about all the participants and even for us. So I will also welcome all the team member and the many person from the JIS College of Engineering, those who have joined here and through the WhatsApp, through the YouTube, they are watching our lecture there. Also, I will like to welcome I can see the few of the students also join this part because they want to gather the knowledge. So I would like to welcome all the students also. So Sudipto, we are keen to listen the lecture of the Gabriela Casolino on the dynamic incremental semi-supervised fuzzy clustering for data stream and classification. So I will not waste the much time there. So I will like to hand over the mic to you. Sudipto, over to you.
Thank you. Thank you very much, sir, for your highly motivating words. Now we are moving towards our keynote session. We have a keynote session today on dynamic incremental semi-supervised fuzzy clustering for data stream classification, which will be delivered by Dr. Gabriela Clasilino from the Department of Informatics or Department of Computer Science, University of Bari, Italy. Before initiating this particular program or this today's program, I would like to say a few words about our keynote speaker today. Dr. Castellino is currently working as assistant professor in the CI lab laboratory of the Department of Informatics, as well as it is also known as a computer science, University of Bari. working on machine learning technology applied to web economy domain. This position has been funded by Italian Ministry of Education, University of Research through the European funding project AIM, that is Attraction and International Mobility. Her research activity is focused on computational intelligence with a particular interest for data analysis. Three different domains are there which in which she is working, that is intelligent data analysis, computational intelligence for e-health, that is very prominent domain, as well as data stream mining. Castellino got the BSc from computer science and engineering from University of Bari in the year 2008, as well as she got MSc in computer science in the year 2011 from the same university. She has completed her PhD from Department of Computer Science at the Doctoral School of Computer Science of the Department of Informatics at University of Bari in the year 2015. She is active in her computer science community as reviewer for international journals such as Elsevier Information Science, Expert System with Applications and Pattern Recognition, IEEE Signal Processing Letters, Transaction on Neural Networks and Learning System, Transaction on Knowledge and Data Engineering, and she is in the program committee of different international conferences. She is in the editorial board of International Journal of Electronics as topic editor, and she is the guest editor of the special issue of the same journal. Parallel to her research activity, she carries out teaching activity in the Department of Computer Science, University of Bari, Italy. So without further delay, may I request our keynote speaker to address the gathering with her beautiful keynote address. Over to you, ma'am.
Thank you for your introduction. I'll share my screen. Okay, and then okay. No, sorry. Sorry, there is I have a problem with my sharing. I try again. Okay, let's stop to share. Okay, and then okay, now you should see my presentation, isn't it?
Yes, ma'am. It is visible. So before you start, I would like to say you Happy Teachers Day, madam. Actually, this is celebrated in India. So Happy Teachers Day. This is our day. Means this is the day for teachers. And Happy Teachers Day to all the participants. This is our day. So I hope you enjoy this particular keynote session. Over to you, ma'am. You may continue now.
Okay, thank you. Okay, good morning. As they said, I'm Gabriella Casalino, and I want to thank again the organizers for inviting me. I'm assistant professor at University of Bari, as they said. And in this talk, I will present recent work on data string classification based on semi-supervised fuzzy clustering algorithm. Bari is the second biggest town in the south of Italy, after Naples, that is much more famous. We are in Apulia region, that is the hill of the Buff, as you can see from the figure. And University of Bari has an old history that starts in 1925, whilst the computer science department where I belong to is more recent, and this year we celebrate our 50th anniversary. I work in the computational intelligence laboratory where we focus on nature-inspired approaches such as fuzzy logic, neural networks, and evolutionary algorithms. You can find more information about our research activities at this link. Beyond pure research on themes related to fuzzy logic, neural networks, and interpretability, our research focuses mainly on 5 domains. Computational intelligence for digital health, bioinformatics, gene expression analysis. We collaborate with the National Council of Italian Council, drone vision, understanding visual arts, and finally string data mining, that is the topic of this talk. You can find the links to call for paper that are still open for 2 special issues. The first on computational intelligence for healthcare, and the second on machine learning methods for IoT application in intelligent e-learning and educational system. We have also organized a workshop on visual arts, and the submissions are still open. So if you are interested in these topics, I invite you to look at these links. In this speech, I will talk about DISSFCM, our algorithm for string data classification. The acronym stands for Dynamic Incremental Semi-Supervised Fuzzy C-means. So the keywords of this speech will be data stream, dynamic and incremental processing, semi-supervised classification, fuzzy logic, and more particularly fuzzy clustering. Let's briefly introduce these concepts, and we will discuss later the dynamic and incremental approach of our algorithm. Okay, in standard supervised learning problems, we train the model with pairs of objects and labels, as in the figure. Indeed, you can see that each point representing an object has a color that represents the a priori known class. After the model has learned the classification rules from the training data, we verify it on testing data. The aim is to obtain a data partition. The optimal solution will group data coming from the same class together and from different classes in different groups, as it is shown in the figure. Of course, testing data does not have labels, so as much the model is precise and accurate, the best the classification results will be. In semi-supervised learning, the task is a bit more tricky since some of the data does not have labels. This is the case shown in the picture, where the model is learned from green dots belonging to the green class, red dots belonging to the red class, and white dots that we don't know the class they belong to. Of course, the more elements without labels, the more difficult it is to learn an accurate and precise model. But on the other hand, labeled data are difficult or expensive to obtain, whilst unlabeled data are relatively easy to collect. So these kind of algorithms are suitable for several problems in real domains. Differently from semi-supervised learning, in unsupervised learning, the model is learned from the data. Labels are not yet available, and similarity functions are used to compare data and assign them to different groups. In the example, I have used the geometrical distance as a similarity criterion, and we can see that the 6 dots on the left have been grouped together and the remaining dots in a different group. The aim of clustering methods is to maximize the intra-cluster similarity and maximize the inter-cluster similarity. In hard clustering algorithms, each object belongs exactly to one group, as in the figure. We will see that this doesn't happen in soft or fuzzy clustering that we will see in few slides. Computers do not reason as brain does. Computer reason when they manipulate precise facts that have been reduced to strings of zeros and ones and statements that are either true or false. The human brain can reason with vague assertion or claim that involve uncertainties or value judgments. For example, the air is cool, that speed is fast, she is young. Unlike computers, humans have common sense that enables them to reason in a world where things are partially true. Fuzzy logic is a branch of computational intelligence that enables computers to represent and reason with vague and uncertain concepts used by humans to describe our world. Just to give an idea about what I mean with uncertainty, let's try to define the color light blue that is represented here. Humans have imprecise idea of what a color is. Different people can refer to light blue with different colors. With this one, the one identified with the RGB 0.1, 0.3, 0.6 or similar colors. Fuzzy logic is a mathematical model that is able to represent this uncertainty in order to make machine able to reason and represent it. Fuzzy set theory is based on the concept of partial membership of the elements to a set. A membership function valued in the real unit interval 0, 1 is used to describe the membership. In fact, each element belongs to a set with a membership degree. We say partial truth. Fuzzy sets generalize traditional sets where objects can only take values 0 or 1. They belong or not to a set. As I said, a membership function is used to describe the certainty of each object belonging to each set. If it is 1, the object certainty belongs to a set. If it is 0, it certainly does not belong to the set. Values in the middle between 0 and 1 indicate that the object partially belongs to a set. Of course, every object belongs to each set with a given membership degree. This is very important in fuzzy logic. Okay. If we apply this theory to unsupervised learning, we get soft or fuzzy clustering, where each object is assigned to different groups with certain degree. This is represented in the figure with different shades of color. We have the same points as before, but we can see that they have been assigned to the two groups with different membership values. We can see red and green dot that certainly belong to the green and red groups, the one on the left and right sides of the picture, this one and this one. And then we have orange and light green dots that represents the uncertainty. Indeed, if we consider the geometrical distance as similarity measure, the two dots in the center, just to make an example, do not certainly belong to the first or the second group. Saying that they belong to the first and the second group with a possibility of 0.5 is more similar to the way our brain reasons. Of course, starting from this fuzzy representation, it is possible to obtain a hard or crisp partition through the fuzzification process. The easiest way is to assign each object, each dot in this case, to the class it mostly belongs to. The last keyword for this speech is data stream. Recently, there is a huge increase in the amount of data that are not static, but coming as a sequence of data that arrives in a continuous and changing manner. It is impractical to store and use this data in this form, and classical data mining techniques are not suitable anymore to deal with this kind of data. So new models are needed in order to process them. Particularly, we need to process a finite number of data at a time, use a limited amount of memory, and predict, classify at any time and in a limited amount of time, but taking into account the evolution of data. For this reason, there are enormous research activities in the field of data stream mining that includes classification, clustering, prediction, and so on. Incremental algorithms are of great relevance because they can learn evolving models without keeping the old data and avoiding the computationally intensive task of retraining the whole model each time new data arrive. So these are the main concepts we will see during this talk. Now let's start talking about our algorithm, the DISSFCM, Dynamic Incremental Semi-Supervised Fuzzy C-means. We have proposed this algorithm. It is a classification method for string data based on semi-supervised fuzzy clustering algorithm by Pedrich. It incrementally learns the models since it is applied to non-overlapping chunks of data so as to enable continuous update of clusters. Moreover, using a splitting and a mapping mechanisms, it dynamically adapts the number of clusters and classes in data. Indeed, a fixed number of clusters and or classes may not capture the evolving structure of data. So we need something that is able to adapt as new data arrive. Just a brief description of the splitting mechanism and the mapping mechanism. When the cluster quality deteriorates from one data chunk to another, the number of clusters is increased by splitting some clusters. The cluster quality at the moment is evaluated in terms of reconstruction error, how well the prototypes and the membership value are able to describe the original data. This is the meaning of the reconstruction error. The cluster having the highest value of the reconstruction error is split into clusters. Then, to find the two new prototypes and data partition, a conditional fuzzy clustering that has been proposed by Pedrich is applied to the data belonging to the cluster. So at the end, we have one cluster that is split in two clusters, and we have two new prototypes, two new membership matrices, but we preserve the label information. The introduction of the cluster splitting implied that there could be different clusters associated to each class. So a mechanism to map the original class labels to the cluster labels is necessary. Data are now elaborated from the point of view of cluster rather than classes. When a new chunk arrives, fuzzy C-means algorithm is applied to each subset of data belonging to the same class. At this time, it's known how many clusters are associated to each class. So fuzzy C-means is used to assign the new data to the cluster labels. Let's see an example, a graphical example, just to better understand how the algorithm works. Data are divided in subsequent chunks containing labeled and unlabeled data. As you can see, in each chunk, we could have labels such as the a priori known classes, red, green, and blue. But there could also be unlabeled data, the white dots. Moreover, image shows that the data distribution changed during the time from one chunk to the subsequent. That is, the number of classes and the number of data belonging to them could change at each time t. Indeed, you can see that in the second chunk, we have more data belonging to the green class, for example. And in the third chunk, a new class appears. We have the blue class. Let's focus on a single step. At each time, dynamical incremental semi-supervised fuzzy C-means is applied to the data in the current chunk, and it returns fuzzy clusters, that is a membership matrix that associates each sample with each cluster with a certain degree, and label prototypes that summarize data in each cluster. Clusters are then used for classification. Indeed, the labels of the closest prototype is assigned to each cluster, to each sample. Okay, when a new chunk arrives, like here, the second chunk is arrived, the process is repeated, starting from the prototypes of the previous chunk. In this way, information about all data are injected in the new chunks. The old model could be no more suitable to describe the new data, as in this case, where the green dots are increased. So a splitting mechanism based on the reconstruction error and the conditional fuzzy clustering are used to create two new prototypes and assign them to the more similar data. Indeed, you can observe that the number of the label prototypes is increased, as well as the number of groups. Okay, now a new chunk is arrived, the third, and a new class is appeared, thanks to the mapping mechanism that decouples the number of a priori known classes from the number of clusters used to the model to describe the data. The algorithm is able to manage the new classes and the data belonging to them. The process continues until there are available data. Indeed, the stream data could be infinite. Okay, this is the theoretical description of our algorithm. I gave you just a sketch. If you are interested, at the end of the seminar, you can find the references. Now we will see some application, and at the end of this presentation, we will see in detail a case study. The algorithm could be applied to any domain where temporal factor is relevant and data are partially labeled. Financial frauds are exponentially growing in the last decades due to money dematerialization. Consequently, credit card fraud is becoming an emerging problem. Fraud detection systems are used to discover and identify fraudulent activities that are already entered in the system. The huge amount of information related to credit card activities makes manual analysis time-consuming and impractical. On the contrary, the study of the customer's behaviors allows to automatically separate legitimate from fraudulent transactions. Due to the dynamic nature of credit card transaction data, incremental learning rather than static learning is suitable for fraud detection. In this context, the assumption of labeled data is quite unrealistic. On the contrary, since investigators provide a feedback to the system in the form of a labeled transaction, partially labeled data are available. Another domain where we have applied our algorithm is occupancy detection. The aim is to detect the absence of people in the room in order to switch off lights, ventilation, and all the tools that will require energy. Since the presence or absence of humans can be used for saving energy and safety purposes, accurate automatic occupancy detection in a building has recently grown attention, focusing on assessment on smart spaces that are aware of their state and then can act accordingly. Sensors are commonly used to measure the state of a room in terms of lights, temperature, humidity, and CO2. Indeed, they allow to automatically infer the presence or absence of people in the room. In the considered dataset, each data sample is defined by 5 features: temperature, relative humidity, lights, CO2, humidity ratio, which have been measured every minute in a room in a defined period. Each sample is classified in one out two possible classes: non-occupied room and occupied room. As a consequence, the dataset is structured as a stream of chronologically sorted data sample, which can be processed as a stream to verify the room condition. A completely different domain is the digital health, where we have applied our algorithm to predict bipolar disorder episodes. Just a second. Bipolar disorder is a chronic mental illness characterized with changing alternate episodes that range from depression, mania, mixed state, and euthymia. Because of the recurrence of these phases, pharmacological and physiological approaches are important to prevent further episodes. However, the frequencies of control visit is usually insufficient to provide early intervention at the start of the episodes. Therefore, in recent years, there is an increasing interest for real-time monitoring of bipolar disorder episodes with the use of smartphones. Acoustic features that are obtained from the interaction of patients with ad hoc application have been shown to be valid markers in detecting bipolar disorder phases. However, data collected with these devices are partially labeled, since only the medical expert can verify the actual state of the patient. As it is easily to understand, in this context, the time is an important component that has to be taken into account. This is an ongoing work that we are on which we are working on with the Polish Academy of Science, and you can find some references at the end. It's a very interesting topic and even very difficult to approach. Finally, the last example I will show you is about virtual learning environments data analysis. I will use this case study to briefly show you the behavior of our algorithm and how it can be used to analyze and interpret data coming from these platforms. Virtual learning environments are becoming very popular with the advent of internet and with the coronavirus. These are online learning platforms where the teaching materials are collected, so the distances between the students and the courses is reduced or completely deleted. They provide synchronous and asynchronous tools such as chat, forum, wiki to support the students but above all, they trace the student's behavior. Any interaction with the platform is stored. Educational data mining uses machine learning to analyze data referring to the interaction among the students and these platforms in order to extract knowledge or to construct models. For example, to predict the students' outcome. Will they succeed or fail in exams? This could be a task. This is another domain where data arrive continuously during the time and they evolve. So our algorithm was suitable to process this kind of data. Four are the main steps involved in educational data mining. The first one, we have data collection. Different kind of data are represented in a structured form, such as a database mostly. Data pre-processing, data are filtered depending on data analysis goal. Not all the data are useful for your aim. Data analysis, where machine learning methods are applied to extract knowledge or to design a model. And finally, results coming from automatic methods need to be interpreted by domain experts. In this study, we have used a subset of the Open University Learning Analytics dataset. The Open University is one of the largest distance learning university, providing free open data related to the online courses. It contains demographic data together with aggregated clickstream data of students' interaction in virtual learning environments, collected on daily basis. Data represents the students' interaction with the educational materials for the academic years 2013 and 2014. Since the goal of the analysis is to predict the student's outcome, we selected the general student information, information about the interaction between the students and the platform, for example, the number of clicks on the course homepage, the number of contribution to the wiki page, the number of quiz that have been performed, etc., and the student assessments information. In this work, we have used semesters as temporal unit. So we have trained the model on the actual semester and we have tested it on the subsequent one. So at the end, 4 chunks have been processed, and at each time, prototypes and membership matrices are returned together with classification results. As can we see, the algorithm returns classification performances for each cluster. As a new chunk arrives, it adapts its model to the new data without the need of saving the old data. The more are the processed data, the more the model is able to describe the new incoming data. I would like to highlight that since the algorithm is based on fuzzy clustering, its results are interpretable. Each prototype summarizes the attributes of all the students' items belonging to that cluster. Particularly, it is a medoid, so in this sense, it can be interpreted as a typical student profile. As an example, in table 1, the attributes A1, A19 of the 2 prototypes P1 and P2 that were generated from the first chunk are reported. The first prototype corresponds to the class fail, and the second prototypes correspond to the class pass. As you can see, for each attribute we have numerical algorithm is a numerical algorithm. We can observe that the 2 clusters, and in this case the 2 classes, share some similarities, such as low education level. We have attribute 2 equals to 1, that corresponds to no formal quals. Age band between 35 and 55, that corresponds to value 2 for attribute 4, and no disabilities as reported from attribute 7. On the contrary, we can observe some differences between attributes in the two clusters. Prototype 2, for example, representing students that have passed the module exams, so they belong to the class pass, show higher interaction values with the virtual learning environments. The values for the attributes between A10 and A19 are higher than the corresponding one for prototype 1 that corresponds to the class fail. This is an easily predictable result. Particularly, the prototype gives information about the learning supports that are more related with the final outcomes. For example, among the learning platform resources, the more discriminant one in terms of class separation are the number of homepage visualization that corresponds to the attribute 13. The number of out collaboration, the number of visited subpage, the number of external URL that have been visited. These results could be used by the teachers as feedback useful to guide the course design and mostly to support problematic students. These results could be used to extract rules able to describe the algorithm results. For example, if number of clicks on forum are high and number of out collaboration are high, and etc., the students will probably pass the exams. Of course, to better represent the human reasoning, these rules could be fuzzy. In this way, we can represent in an imprecise way the concept high, low, and etc. However, this is a working task. We have still not implemented the explanation of this feature, but we are working on it. The clusters created by our algorithm could be also explored to categorize students' items according to their membership to different clusters. In the figure, there is a graphical representation of the membership matrix returned by the fuzzy clustering algorithm for the first chunk. Rows indicate students' items and columns correspond to the two clusters. Each cell in the matrix indicates the membership degree of a student's item to a cluster. This membership degree can be interpreted as a matching degree indicating how well each cluster prototype describes each student item. Yellow cell indicate high membership values, the maximum value being 1, and blue cells indicate low membership values, the minimum value be 0. Intermediate values are represented with different shades of yellow and blue colors as reported in the legend that you can find here. It can be seen that for the most of the student items, the membership to the first and the second cluster are well defined. We have yellow or blue. This means that such items have high matching degree to one of the prototypes and very low degree to the remaining one. On the contrary, For some students item, the one that are highlighted here, the student 10 and student 22, we observe shaded color gradation. This means that student item is described by both prototype with a different certainty degree. These results could be used to group items accordingly to their profile. For example, students 1, 2, 3, 5, 6, etc. will be grouped together in the cluster corresponding to the first prototype, whose class label is fail. On the contrary, students 4, 7, 8, etc. will be grouped in another cluster corresponding to the class pass. In this way, students can be supported differently depending on their membership degree to each cluster, and special attention could be given to students belonging to class fail. Of course, in this example, I've shown the results coming from one single chunk. In real data analysis processes, we have prototypes and membership matrices for each chunk. So we could observe changes among students' classification during the time, together with a change in data distribution. For example, two prototypes could be no more suitable to describe the students in the chunk. So more prototypes labeled with the original classes fail and pass could emerge during the computation. In the same way, if a different target class occurs in a chunk, for example, distinction or withdrawn, a new prototype will be generated to describe data belonging to this class. I hope that my presentation was clear enough. If you have doubt, you can ask me, or you can refer to our works. I will give, I don't know how, but I can send you this presentation, the PDF of this presentation. And thank you for all. Thanks again.
Thank you very much, ma'am. It was a wonderful session. We are very happy and very delighted also after listening your entire presentation. I would like to say to the participants that if you are having any question from this particular session, you may write it in the YouTube chat so that we can take that question and can praise this question in front of ma'am. Okay, so you please write that question in the chat window of the YouTube live. Amit sir, I think there are some questions that already been asked. So Amit sir, over to you. You may conduct this session, question answer session.
Now, hello Sudipto, till now I have collected 2 questions.
Okay.
So I am just going to post the question in the chat box. Madam, you just look over in the chat box, you will find there. I have already posted 1 question.
Yeah, this is a very interesting question. Yeah, we use reconstruction error to evaluate the quality of the clusters. If we see that after a split, the quality of the remaining clusters I'm answering to the first question. The first question is when a cluster is split into 2 clusters, then you can prove that the efficiency of the system is increased. No, at the moment we can't, but we can monitoring the reconstruction error. What we do at the moment, we plot the reconstruction error, and if it increase too much, it means that it is not working. So we have a stopping criteria that limited the splitting, although we could reach a high number of clusters. But you are right, we are working on a measure to evaluate the cluster, the quality of the resulting clusters. We are thinking about internal measures, since we are using clustering algorithms. But since we also have labels information, even if it's partial label information, we are thinking about a measure that takes into account both labeled and unlabeled data. We are working on this point. This is a very good point. Thanks for asking. And the second question, in supervised learning, you have used the semi-fuzzy clustering method. What is the difference between semi-fuzzy and fuzzy clustering algorithm? Okay, fuzzy clustering works is an unsupervised learning method. Semi-supervised fuzzy clustering works with both labeled and unlabeled data. So this is the main difference. We use the semi-supervised fuzzy clustering by Pedrich, but we adapted its algorithm in an incremental way. This was the first change that we did, and then we improve it with the dynamic characteristic with the split and mapping mechanism. I hope I was able to answer to the question.
Madam, third question. I have posted it.
What are the limitations of our algorithm and its complexity? Another very good question. Its complexity. We have not evaluated its complexity. I actually can't say its complexity. I don't want to answer to this question because I can say something that it's not wrong. I will check and I will let you know. And the limitation of our algorithm, okay, we need to process, we process data group in chunks that are subset of data. The number of data in each chunk influence the results. Of course, the more are the data in the chunks, in each chunk, the better the results will be. So this is a limitation of our algorithm, but most of the stream data clustering algorithms work in a similar way. They mostly have a batch part where we learn the model, and then an incremental part where they test the model to the data, to the incoming data. Another limitation of it's not a limitation, it's normal. Since we use clustering algorithm for classification, we learn from the geometrical structure of data. Sometimes it could happen that the geometrical structure of data does not correspond to the a priori known classes. So sometimes we could obtain good clusters, but they do not correspond to the classification that humans have done. This happened, for example, in the work on bipolar disorder, where we have data that have been manually labeled by the medical expert, and but the data have been collected through this app, and we have seen that probably we are still studying the data, but probably the labels that have been assigned by the doctor are not don't correspond to the real nature of data, because what we get from the data structure, I mean similarity among data, is not what doctor says. So we are still working on this. There is another question. On which factors data interpretation depends? Any limitation? How is safety maintained? About the interpretation, I would say about the explainability. The limitation depends for sure on the number of data. The more the data are, the more difficult is the explanation, and the number of attributes, because the more the attributes are, the most difficult is to explain them. But as I said, this is an ongoing project. We are working on that. But it is promising because prototypes represent they are representative of groups of data. And I think that this is a good way to extract rules. And since we are using fuzzy logic, using fuzzy inference systems that are reasoning systems that use rules in form of that use fuzzy logics could be a good way. So,
Madam, another question is there. I'm just going to post it.
By any virus, the question is, explain how security of algorithms maintained. Is it affected by any virus? To be honest, I don't know. We have not studied this. The algorithm from this point of view. So I don't know. Because we have run the algorithm on our laptop, so we didn't consider the virus attack.
And another question, madam.
Yeah. When there is necessity to use fuzzy logic is used to represent uncertainty, or in the example that I did, she is young. I'm not saying she's 20 or she's 21. I'm not defining a threshold that selects young people and old people. Fuzzy logic is used to define smooth chains. So it could be confused with the probability, but probability is used to define something that will happen. On the contrary, fuzzy logic is used to define something that is already happened. We can use fuzzy logic every time we need to represent uncertainty, vagueness, and so on. I think that recommender systems, for example, if you want to define your user, you can use fuzzy logic. An user, for example, if you think about a user can like an object highly or not, instead of using numerical crisp values, you can use fuzzy logic to have soft reasoning. There are several applications, even in robot control, in robot control system. If you need to control the movement of robots, fuzzy logic could help, because you don't have hard choices, but you have soft changes and soft choices. Can we use your algorithm to improve the clustering in wireless sensors network to save energy consumption? Yes, this is not a domain that I know very well, but I know that in wireless sensor networks, you have the need to save energy. And since you collect data sequentially, yes, you could use our algorithm for sure. In your case, I'm not sure if your data are labeled or unlabeled, or you have both labeled and unlabeled data, but in both cases, our algorithm works. I'm happy that the talk interests you. A dataset can possibly have multiple two-set partition, as often seen in multi-label classification. How to select feature for clustering of unlabeled data for different. Okay, to the first question, yes. In the example that I have shown, it was a binary classification problem, but of course we can manage multi-class classification as the bipolar problem, where we have mania, euthymia, depression, and mixed states. So we have 4 states, but you can manage multi-label classification. And how to select feature for clustering on unlabeled data for different possible partitioning. Okay, since behind the algorithm we use fuzzy clustering. Fuzzy clustering uses the geometrical distance, the Euclidean distance, to assign data to groups and then to classes. So even if we don't have labels, we are able to learn the model. Is fuzzy logic replaced by artificial intelligence? No, no at all, because, okay, first of all, artificial intelligence is a bigger area that includes robotics, symbolic and subsymbolic learning. Instead, fuzzy logic refers to numerical learning, where we use natural language terms to represent our attributes and our data. But for sure, fuzzy logic cannot be replaced by artificial intelligence, or the contrary. Fuzzy logic is a subset of the big field of artificial intelligence. Yes, you can use my algorithm in credit card fraud detection. We used it, and I'm still working on it. The problem is that in credit card fraud detection is that data set is highly unbalanced. So in the work that we have published, you have the reference in the presentation. I can give you the PDF. We use the actual chunks to model to create the model, and the subsequent chunk to test the model. This is done in literature, but if you think about the problem is not very suitable, since you are assuming that you know the actual data and the future data or the nearly future data. So now we are working on a variant. We are trying to apply resampling methods to each chunk, and we are verifying if it works or not, because the main problem is the unbalanced data. These are very highly unbalanced data. How is fuzzy logic based algorithm better than supervised machine learning algorithms? Okay, I would not say that fuzzy logic are better than supervised. First of all, there could be fuzzy supervised machine learning algorithms. I show you an unsupervised fuzzy algorithm, but usually fuzzy inference systems are supervised. There are supervised and unsupervised fuzzy algorithms. I would not say that one algorithm is better than the other. I would say that there are problems where it's better to apply classical machine learning, and other problems where using fuzzy logic is a good choice. Just to make you an example, we have an intelligent mirror. It obtains vital parameters from video. And then from these vital parameters, we have a fuzzy inference system that is able to predict or to suggest if a person, to predict cardiovascular risk. In that context, medical context mostly, using fuzzy logic is a smart choice, because you are modeling the human way, the way humans reason. So I would not say if, for example, blood pressure is between I don't know, 19 and 30, you are sick, and from 31 to 50 you are healthy. There are gradation, there are shades of certainty. So fuzzy logic is very suitable for medical problems, for just to make an example.
Okay, we'll take one more question. Amit sir, just one
Okay,
question.
Okay, one more question only. Madam, this is the last question.
Okay.
Because many questions have been addressed.
Okay. All right. Can we make hybrid fuzzy image algorithm which is based on bias part? Yeah. Image and answer. Okay. Yes. Yes. Fuzzy logic can be hybridized with a neural network and bio-inspired algorithms. So yes, for sure. You can do that. I'm not expert of image enhancement. My colleague works on vision. He works on video, art, so he's more expert than me. but yes, for sure, you can mix these two kind of algorithms. Fuzzy logic is very used in for image processing, for segmentation, for example.
Madam, you have answered many questions. So before I proceed, Ms. Sudipto, before you
Yes, sir.
proceed,
Yes, yes.
you should give the feedback link in the
Yes, I'm
YouTube
going
live
to share
because
it
you are
shortly.
asking.
I'm going to share it shortly. So we have taken almost every question. So thank you, dear participants, for listening listening actually ma'am's words in a beautiful way. And I hope that all the answer you have got cleared. So thank you, madam, for sharing your thoughts and your nice presentation with us. So in the meantime, I would like to request our Professor Dharampal Singh, as well as other coordinator Amit Majumdar sir and Pranati ma'am, to convey a small token of appreciation on behalf of our computer science and engineering department. I am going to share the screen. All of you, please do the honor. I'm requesting each and every faculty member. That will be better. I think this is on this occasion of Teachers' Day. All the faculty members and Subhenduda is also here, and all the staff members from Department of CSE. I am sharing the screen. You all please do the honor. Just let me one moment. Okay. So all of you please convey this small token of appreciation to ma'am
Accept
for
this
his
one
wonderful
from
session.
our side. Thank you.
Thank
Thank
you.
you, madam. Accept this
No, thank
from the
you
Department
for
of Computer Science, JS College of Engineering.
thank you for your questions. They were very interesting and they will help my work. If you are interested in my work, you can contact me by email. I will give you all my contacts. Thank you. Thank you
Sure,
so much.
sure, madam, sure. Thank you.
Thank you. Now I am going to stop the screen sharing, as well as I am going to share the feedback with the participants. Just give me 1 minute more.
Hello.
Yes, sir. Sir, DBS sir, you may proceed. You may continue with some words.
Hi. Actually, it seems like that due to network problem, I was not able to communicate properly. Well, I'm saying something, but you are not listening. It may be possible due to link with it. So actually,
Sir.
thank you, Gabriela, for your wonderful session. As you know that this is auspicious day for the in our country. Today is the Teachers' Day. So already my faculty already given the one token of appreciation to you. So also from my core of that, because I have contacted you many times, that from my core of that, kindly accept this one and do the honor to us by accepting this one. Already I have seen that you have accepted. One more time you can accept it and make us honor there. But one more thing I can say that throughout the session I have watched it, and from the chat board what I have seen that our participant totally mesmerized by the your session, that, and I can say that you have enthralled us. When from the beginning to the end, we can say participant are typing, they're very good and informative session. So thank you, Gabriela, for your wonderful session one more time. Thank you.
Thank you to all of you. Thanks.
Thank you. Thank you very much, ma'am. Now I would like to call our Dr. Pranati Rakhi, Senior Faculty Member of Computer Science and Engineering Department from JS College of Engineering, to convey the vote of thanks. Ma'am, please.
First of all, I like to thank our today's eminent speaker, Professor Gabriela Casalino, for her excellent and informative speech. Thank you, ma'am. Thank you very much. Then I like to thank on behalf of our CSE department, I like to thank our MD sir for his continuous inspiration to do such type of FDP. Then I like to thank our director sir, Dr. Molayar Dave. I like to thank principal sir, Professor Partho Sarkar. Then I like to thank all the deans, Then I like to thank our HOD, Dr. Dharampal Singh, our host, Sudipta Shahana, and all the faculty members of CSE department and all the coordinators of today's session, and all the technical staff of CSE department. And finally, I like to thank all the participants who are here and without whom this occasion or today's FDP will not be possible. So thank you all very much.
Thank you very much, ma'am. Ma'am, Castellino, ma'am, I'm sharing the YouTube link with you. You may share, means your lecture will be recorded in that particular link. That YouTube link I have shared, you may take it with yourself. Okay. So, ma'am, it was a wonderful session. Thank you very much for joining with us. And I will request that you please continue your support with our department and as well as JS College of Engineering. So thank you very much. In the meantime, I would like to request each and every faculty member, those who are present in the Zoom platform, please turn on your webcam so that we can take a good snap. Everyone, please. Amit sir?
Yes, Sudipto, it is
Amit
not
sir,
possible. I am with a laptop. It is not possible. Webcam is not working.
Okay, Amit sir, you please take the snapshot. I would like to take snapshot from YouTube also.
Okay, I am taking it.
Kira madam, Jhumpa madam, Apurva sir, if possible for you, please turn on the webcam. Okay. So thank you very much, ma'am, for joining with us.
Thank you.
Your long association is highly appreciable, ma'am. Kindly stay connected with us. We'll again ping you for such nice presentations once again. Not once again and again actually. So thank you for joining with us. So everyone, every participants, thank you very much for participating in this wonderful session. And one more time, I would like to say Happy Teachers Day to everyone. So today we have completed our 4th day of this FDP, and again we will start our 5th and final day of this FDP program by tomorrow. That is at 7:30 p.m. So till then, Dipesh sir, you would like to say something?
No.
Okay, fine.
At the end, no. Only Happy Teachers Day I want to say.
Okay. Happy Teachers Day to everyone. So we'll have our 5th session, that is 5th session by tomorrow. That is on 6th of September at 7:30 IST. So thank you very much. Till then, good night. Stay safe. Bye everyone.
Bye. Thank you
Take care.
again.
Sir, I am closing the session. Thank you.